Okay, I'm going to whip through this with you guys. Integration of exponential functions. So hello, calculus students. Be good today. It's last day of the full week here. We got a half day tomorrow. So here we go. Day 2 of this 5-4 section. Now what I'm going to do is talk to you about integrating e to the x. Well, we know the integral of e to the x is itself, it's e to the x. So that's the very simplest case you could have. So why don't you go ahead and jot down that this is the integral for e to the x. Also, you may want to take note of the integral of e to u, where u is some expression, right? It's a little bit more complicated than just an x. The integral for e to the u is also e to the u. The only thing is, with this, we'll want to do a u substitution just to see if there is a coefficient that should be written down in front of our e to the u as we integrate. So those are the two items that you need to get in your notes. And you may want to hit pause for some of you to get this down. I'm going to go ahead and move forward here. And there are only 3 problems we're working through today, so it's rather short, but they can be a little complicated. So my first one, I guess those are attached. This does say e to the x, or e to the square root x. What I want to do is, this is not just a clean, simple x, is it? It's really e to the x to the 1/2 power over square root x, or it's an x to the 1/2 power if you would rather see it that way. This requires a little u substitution, so I'm going to let my u equal x to the 1/2 power. Take the derivative of that, and we get a 1/2 x, subtract 1 from the power, and we're at negative 1/2, plus dx. Multiply by that dx. As I look over here to the left, I do not see a number other than 1 sitting in front of my e, but here I'm seeing that 1/2. So let's multiply by 2 on each side, so we get 2 du is equal to x to the negative 1/2 dx. And you're probably like, well, Mrs. Oppold, x to the negative 1/2, I see x to the 1/2. Yeah, but let's look. That's actually in the denominator. So that's what would happen with this negative, right? The negative would be pushing the x value to the denominator. So then we have a nice matchup. I have this in place, don't I? I really, if I wanted to analyze this very carefully, I could say I have that. E to the square root x, or x to the 1/2, 1 over x to the 1/2 dx. Now, this is a perfect match for over here. So we're going to substitute 2 du for that. I'm going to substitute u for this x to the 1/2. So we get e to the u, and then 2 du will go in place of this object, right? And now that's easy integration. Remember our integral rules here. The integral of e to the u is e to the u, but I warned you, we've got to check substitution because, or that u sub, because we are going to pick up a coefficient of 2, and then it's e to the u plus c, or 2e, let's replace that u, bring it back, x to the 1/2. I like the square root of x, so I'm going to write it that way. It just looks nicer. So there's our answer. See if you can follow that through. All right, let's do 93 next. Hit pause if you needed to. 93. Well, that looks like quite a mess. I'm going to go with my gut instinct, which is to typically grab the denominator, especially because things look so equal between top and bottom, that my gut instinct says, let's let u equal this bottom stuff. You know, and sometimes in math, you just got to take a start, try something. If it doesn't work, scrap it and replace it and try something different. So my gut instinct is, let's give this a try using the bottom. Take the derivative of each side. The derivative of e to the x is e to the x minus the derivative of e to the negative x. It is itself e to the negative x times the chain rule, and the derivative of negative x produces a new negative. And then this would have been over dx, right? But we just often say we're multiplying it up and bring it over right away. All right, so I'm going to just clean up my line. And I change that negative into a positive. Now, a wonderful thing happened, right? Did you see that we have now got that top portion and the dx sitting right here? Amazing! You know, some of these are set up so nicely, but it's a good way to start learning how to do these. If they made them horrific at the beginning, we'd never stand a chance. So we've got to have some nice ones once in a while. All right, so our u portion was this, which matches with that, right? So I put it as 1 over u as I'm writing my integral here. So 1 over u is the yellow. The blue is going to get strictly replaced with du, isn't it? And now the integral of 1 over u, I hope you recognize the pattern. Natural log absolute value of u plus c. And then we don't want to leave it with absolute, or the u, so we'll change it back. I'm looking over here now to the yellow again, and it says u is equal to e to the x minus e to the negative x. And unfortunately, there's nothing we can do to simplify on that. That's our answer. All right, let's move to 97. I'm going to hit clear. If you need this a little bit, just please pause it. All right, number 97. Gut instinct. What do you think, guys? I mean, I can kind of see two choices. I see one function here, just that e to the negative x, and the other function that I'm eyeing is the tan of e to the negative x. So my eyes are really drawn mainly to this guy up here because it's a composite function. And I think ideally it's the inside piece I should let be my u. So I'm going to do that, and maybe I'm wrong, but I can always try again, right? That's what erasers are for. So let's let u be that inside piece, e to the negative x. Pass through the derivative stage, so the derivative of e to the negative x is e to the negative x. Chain rule, the derivative of that top piece is a negative, and then we can multiply by that dx. This is really close. I'm looking at the blue highlight over on the other side, and I'm pretty darn close, right? We just don't need the negative that's coming along here. All right, so we can get rid of our negative. Multiply both sides by a negative, we get negative du as e to the negative x dx, and we are in business. So let's rewrite our integral with all these u's. I replaced the e to the negative x with a u, so this will be tangent of u. The e negative x dx gets replaced with negative du, right? Because here's my e to the negative x. So this will be negative du. And, oh, I can integrate tan. Not the easiest integral. I have to remember a little bit. Okay, so we got the negative coming down. Now, the integral of tan we learned the other day, I think it was section 5.2, it's negative. Natural log absolute value of cosine of u then plus c. And maybe you don't remember that, but look back in your notes and you're going to see that oddball one, the integral of tan. Negative makes positive, so we are positive natural log absolute value cosine. Switch out the u. What was u originally? U was this e to the negative x plus c. And we are done. That is your answer. So positive there. All right, what you'll have on the back side are the notes, or I'm sorry, the problems that you should work on. And just go ahead and work through that. I'll give you a hint on 86. I would let my u equal that. Okay? And for 88, I would let my u equal that. And I would also rewrite this. I would rewrite this as e x to the negative 2 over x to the third. Now let e to the negative 2 be your u. Okay? And I bet you can guess on 90 and 92 what you should let your u equal. On 98, this really simplifies. So I would do the simplification, you guys. This cancels, doesn't it? And then I can think of this as an integral of 2x minus 1 dx. I can go that route. Otherwise, the other option is you can let u equal that and it'll work out too. So your choice on that. Please have those done for tomorrow. And I will open up a WebAssign as well that we're going to work on Friday, so that if you want to get a head start, perhaps these 5 problems aren't going to take you the entire hour. And I'll see you Friday. Bye-bye, guys.